Today going to the case study video, completely randomized design case study. See that case study problem.
We are going to see the case study problem. First, the question is a completely randomized design experiment with 10 plots and 3 treatments gave the following designs. So here they have given the plot number, treatment and the E. Now let's analyze the result for the treatment effect. First, we have to arrange the elements in the ABC order. So A, B, C we have written as x1, x2 and x3. 5, 7, 3, 1, 4, 4, 7, 3, 5. Next, x1, x2, x3 total. Next we are finding x1 the whole square, x2 the whole square and x3 the whole square. So for finding the total we have to just add x1 plus x2 plus x3. Here 5 plus 4 plus 3 which is equal to 12, 7 plus 4 plus 5 which is equal to 16, 3 plus 7 plus 1 which is equal to 11 and 1 which is equal to 1. So here we have to give the summation of x1 which is equal to 16 and summation of x2 which is equal to 15, summation of x3 which is equal to 9 and the total is 40. Again for the same thing we are doing for x1 the whole square, x2 the whole square and x3 the whole square. So square of 5 square is 25, 4, 16, 3 square is 9, 7 square 49, 4 square 16 and 5 square 25, 3 square 9, 7 square 49 and 1 square 1. So again we are doing the summation. So summation of x1 is whole square is equal to 84, x2 the whole square is equal to 81 and summation of x3 the whole square is equal to 35. Now H0 is that there is no significance difference between the columns and H1 is not the significance difference between the columns. So first thing we are finding the n. N means the number of data. So here the total number of data is, the plot number is 10, so we are writing as n is equal to 10 and find the t value which is equal to 40. Again for the treatment we are just adding all the yield values to get the treatment value which is equal to 40. CF which is also known as correction factor which is equal to t square by n. So t square is equal to 40 the whole square because total value is 40 square by 10 which is equal to 160. Again we are finding TSS total sum of square. We are adding the summation of x1 square plus summation of x2 square plus summation of x3 square minus correction factor. So which is equal to summation of x1 square is equal to 84 plus 81 plus 35 which is equal to 160 minus 160 which is equal to 40. Now we are going to find SSC which is the sum of square of column between the columns, summation of x1 the whole square divided by c1 plus summation of x2 the whole square divided by c2 plus summation of x3 the whole square divided by c3 minus cf which is equal to 6. At last we are going to find sum of square for the errors which is equal to total sum of squares minus sum of square of between columns which is equal to 40 minus 6 which is equal to 34. Now we are going to find the ANOVA table. So first source of variation, degree of freedom, sum of squares, mean sum of square, variance ratio and table value. First between the columns and between the errors we are going to find. So for the between the columns, column minus 1, the total column is 3, so 3 minus 1 which is equal to 2. And sum of squares of between columns is equal to 6. We are finding the mean value for the columns. So SC minus divided by C minus 1 which is equal to 6 divided by 3 which is equal to 3. Again for the variance ratio we are finding MSE divided by MSC which is equal to 4.857 divided by 3. So next we are finding for the errors N minus C which is equal to 10 minus 3 which is equal to 7. Already we have found the n value and the column is 3, so 10 minus 3 which is equal to 7. And sum of square of error is equal to 34. Now we are going to find the mean sum of square which is equal to sum of square error divided by number of total number minus columns. So 34 divided by 7 which is equal to 4.8%. Next for the variance ratio we have calculated as 1.62 and for the table value we need the table to find the values. So here we have found that f of alpha which is less than is greater than 19.35. So we can accept the H0 value, where H0 is there is no significant difference between the columns.
Next, going to the application of the engineering applications of completely randomized design. Tell me.
So the applications of completely randomized design. The completely randomized design is a basic experimental design commonly used in research and engineering when experimental rules are homogeneous. Material testing. So testing different types of concrete mixers such as ABC to measure compressive strength. Its applications are each sample is randomizedly assigned to mix type to ensure no bias in the assignment process. Helps evaluate which mix performs best under the same conditions. So quality control and product testing. Example, comparing different brands of lubricants for machinery wear reduction. Applications are assign lubricant types randomly to identical machine parts and compare wear levels after a set of period. Next, manufacturing process optimization. Example, evaluating different cutting tools or parameters in CNC machining. Applications, random assignment of cutting tools to identical workpieces to study effects on surface finish of food water. Environmental engineering, testing water treatment methods. Applications, random assignment of treatment methods to identical water samples to compare effectiveness in removing contaminants. Agricultural engineering, testing different irrigation techniques on crop yield in identical plots. Irrigation methods are assigned